at the top of the hour. So we are going to go ahead and get the webinar started on oil sample point optimization. My name is Heather Versillo. I'm with Testoil, and I've been with Testoil for almost 10 years now. I'm our marketing coordinator, and I also hold my CLS certification. But I'd really like to present Evan Zabowski. He will be presenting today's webinar. And Evan is a certified lubrication specialist with diplomas in chemical engineering and fourth class power engineering. He has extensive experience training tradesmen and professionals in a variety of fields that include lubrication fundamentals, contamination control, condition monitoring, RCM, FMEA, and used oil analysis. He's also been a member of STLE for almost 20 years and has served as the chair of the Alberta section for 8 years. He's been an instructor of the condition monitoring courses through STLE's annual meetings and has also been on the board. Currently, he's serving as his 8th year as editor of TLT and was the editor for the STLE Alberta section's Basic Handbook of Lubrication, the 3rd edition. And he's contributed as one of the editors for STLE CRC's Handbook of Lubrication and Tribology, the Volume 2. In addition, Evan's published several technical papers, and he's also been a member and currently a member of API and ASTM. And as we move through today's presentation, if you have any questions for Evan that you would like answered, there is a question section in your GoToMeeting or GoToWebinar toolbar. There is also a chat where you can post any comments or questions, or if you have technical difficulty, and I can go ahead and help you out during that time. And without further ado, Evan, go ahead and take us away on oil sample point optimization.
All right, thank you, Heather. So yes, today's presentation is on oil sample point optimization. Basically, we're going to run through about 5 steps. First step is how to select if you should even sample the equipment, and then where you would sample that piece of equipment. Then we'll get into the procedures and frequencies and show you a little bit of tools. But the first thing I'd like to start with is a discussion about the importance of sampling and sampling well. So what we need to discuss is why sampling is considered the foundation of the program, because essentially if you don't do this step right, the rest of the program falls apart. So the easiest way to think about how to take a good sample or what you need to take a good sample is consistency. We need a consistent location, we need a consistent procedure, and the one thing a lot of people don't seem to pay that much attention to is a consistent frequency. It helps smooth out the data so we can best see the trends if we can maintain all 3 of these consistencies. Essentially, I like to summarize taking an oil sample is all about establishing what is normal. And we can't figure out what normal is if we don't have good data coming in. Because what we want to see is a smooth trend. It could be flat, it could be slightly up, it could be slightly down, it doesn't really matter. But when we do see a deviation in the trend, that's when we know things are not normal, and that's when we take further action. So that is essentially the foundation of a good oil analysis program. So what we'd like to do is establish normal by taking what you would call a representative sample. The problem with the word representative is it's hard to define the term representative without using the word within the definition. And generally when we mean representative, we actually have 2 sides to that definition. First and foremost is it's representative as in it's showing you what you want to see. Right? If you're concerned about the contamination levels in your sample or in your machine, would you take a sample before or after a filter? Well, obviously you would think we should take it before the filter because the filter will remove the contaminants and we wouldn't see them if we sampled it after the filter. On the other hand, if you were concerned about seeing how clean the oil was being delivered to the machine, would you take a sample before or after the filter? Well, in this case, you would take it after the filter because you'd want to see how clean was the oil going to the machine. So representative means what you want to see. Like, do you want to see how dirty it is or do you want to see how clean it is, as an example? But the other side of it is representative in the manner in which it is taken. Are you collecting the first stuff that comes out of the sampling, plug, port, valve, whatever you have? Well, that's not going to be very representative. That's not live circulating oil. It's not well mixed. It's not representative of the conditions behind that valve. So representative is seen from 2 perspectives. It's of the area of concern, what you want to know, and it's taken in such a way that it will tell you that as best as possible. So what I like to do is explain that if you don't do this, if you think that there's a shortcut to this and you can make it a little bit easier, you don't have to pay that much attention to it, what you're going to end up with either some false positives or some false negatives. If you have a lot of false negatives, meaning that you don't see things that you should be seeing, you're going to have some unscheduled downtime because you'll miss problems that you should have caught. On the other hand, if you take it in such a way that you get a lot of false positives, meaning you get a lot of data indicating abnormalities, when in truth there isn't any, you're going to end up chasing your own tail, fixing things that don't need to be fixed, doing inspections that don't need to occur. So what we need to concentrate on is how we can make these samples representative, how we can find normal as easily as possible. So my logic is, if you're going to take bad samples, it's best not to even sample. That's just a waste of everyone's time and effort. So there's no point doing that. Now, obviously, because of today's presentation, we'd like to learn a bit about taking good samples and having a good program. So taking a good sample is better than not sampling at all. But my point is, taking a sample from a really great location, even if you're not using the best of procedures, is better than anything else you can do at the moment. Let me give you a hypothetical just to explain that logic. Imagine you've got yourself a system. It has a reservoir somewhere in it, and it's got filtration. Now, the filtration does not have to be on the reservoir. It's just somewhere within the lubrication loop. Now, sample number one, your first choice of where to sample, is to take a sample from the reservoir, but the only point you have is a low point drain on the reservoir. So you approach the reservoir, kick open the drain valve, let it flow for 10 full seconds, complete flush of the drain valve. Then you collect the next 4 ounces of sample, cap it, that is sample number one. The comparison then is sample number 2. You approach your filtration. You go to the dirty side, the inlet side of the filters, before the oil goes into the filters. You open up that plug or port or valve that you've got there, and you take absolutely the first 4 ounces that comes out of that particular area. So sample number 1 is a well-flushed sample from the drain. Sample number 2 is a not flushed sample from the filter inlet. Which of those 2 samples is going to give you a better idea of what is going on inside the system? Well, hopefully you're thinking sample number 2. It's the only one that shows you live circulating oil. As good as the procedure was in the reservoir, taking a well-flushed reservoir sample at the drain is only going to tell you what's at the bottom of your reservoir. And generally, you don't care. It's supposed to be a garbage pit. It's supposed to be where the water settles out, the particulate settles out. You don't need to see that. You want to see what's going around through the machine. So the not flush sample at the filter inlet is the better of those 2 samples. Now, obviously, that's not still a great sample. A great sample would be from that great location and the proper procedure. But my point is, it's hard to change a location. It's easy to update a procedure. So always work on the location first. Get that solid. Once you have that, you can always tweak your procedure later and get a good sampling program. So what I'd like to show you then is how to find these sample point locations. But before we get too far into that, let's decide if we should even sample it. Because there's no point sampling every piece of equipment you have on site. That is not useful. That just provides you with a lot of data, and some people call it analysis paralysis. Just too much data coming in, and you can't spend the time to properly look at it all. So you'd like to focus on the key pieces of equipment that need analysis. And so essentially, I've come up with a list of 6 criteria. And these 6 criteria, you have to meet at least one of them. You don't have to meet more than one. You don't have to meet all 6. But if you can't meet any of these criteria, you have to ask yourself, is it worth sampling? So let's go through these in a little bit more detail. So the first criteria is it critical? If you say yes, it is critical to plant operations, it's critical to what I'm doing, then it is worth sampling. But if you look at it and say, no, I've got that in duplicate, triplicate, if one of them goes down, the other one turns on, there may not be a need to sample that particular piece of equipment. The next thing I'd ask is it designed for safety? So I don't mean is there a safety concern if there's a failure. I mean, is it designed to provide safety? Is it the emergency backstop on a conveyor belt? Is it the braking system on an elevator? Is it a fire water system for your plant? If it is designed for safety, you may not view that as a critical piece of equipment for operation, but it's still critical to the overall reliability of the entire facility. Next, I'll ask you, is it expensive? And by expensive, I mean, is it costly to purchase, to repair, to replace? What about its downtime? If it hurts your company financially when this equipment does not run the way it should, then again, it is probably worth sampling. Next, I'll ask you, is it unreliable? If it's very reliable, if you purchase a pump, as an example, that's supposed to provide you between 8,000 and 10,000 hours of service, and you get 2 years out of it, that's more than what you expected. There's no reason to put any sort of strain on your reliability program, keeping tabs on a pump that runs longer than it was meant to. But if you say yes, it is unreliable, it does not operate the way it should, we've had unexpected failures and trips, it is probably worth sampling. Next, I'll ask you, is it suffering from any sort of inefficiencies? Is it not meeting its normal efficiency? Right? Is it not producing as much as it should? Is it running hotter than maybe it's expected? Anything that would indicate that it's not producing the way it was intended to produce, or at least has historically produced, it may be worth sampling. And the last thing I'll ask is it operating in an extreme environment? Is it working where it's particularly humid, particularly dirty, particularly hot? Any of these extremes could put undue stress on the machine, and it would be worth sampling. But if you've gone through that checklist of the 6 criteria and have said no to every one of those questions, I would ask you, why are we sampling it? What do you need from this? Because you've not given me any strong indication that there's a need to sample that particular machine. So like I said, assuming it meets at least one of those criteria, we move on and say, where should we sample it? And the where becomes a bit more complicated, but the goal is that first consistency. We want to find that location that we can always sample from. So we need to keep that in mind. The practicality will play a bit of a role in this. But the other thing we're looking at is, what are we hoping to get out of the program? So generally speaking, here are the 4 top choices as to why people are performing oil analysis. Number 1 reason would be something like they're trying to save on oil costs. They're trying to extend their drain intervals, reduce the downtime, reduce the amount of oil they're purchasing, just in general, reduce some overall cost and effort. Another one, though, is they could be trying to reduce the mean time between rebuilds or replacements, right? Extending equipment life. In many industries, one of the key criteria we're looking for is to monitor contamination, because we know contamination tends to be the number 1 driver behind equipment failures. And last but not least, a lot of people track things like reliability or uptime. And if we're looking to increase or maintain that value, again, that will help guide us as to where we're going to sample it. Now, some people read this list and say, hey, all 4 of those sound great. Let's do all 4. My problem is that the sample that will tell you the answer to one of those 4 questions may not tell you the answer to the other 4 questions. So we need to pick which one's most important to us and guide our sample point selection based on whether or not it'll give us that data. So let me give you an example. Let's walk through a very simple lubrication skid. So this skid here is providing lubricant to a machine that we don't see in the picture. Doesn't matter what that machine is. It could be a pump, a compressor, a gearbox, a turbine, it doesn't matter. But this is where our lubricant is coming back to. So hopefully you can see that it's a reservoir. On top of it, it has a couple of pumps. On the side, it has a couple of filters. So when we look at this, we can answer all 4 questions by taking a different sample. If you look at it from a reliability or criticality standpoint, you might say those pumps are critical. Without the pumps, we're not circulating the lubricant. And without circulating the lubricant, well, the machine that we're trying to lubricate will trip, will fail. So our sample point location becomes, we should sample from the pump outlets. That would tell us if the pumps were about to fail. However, some people look at this picture and say, wait a minute, there's 2 pumps. Therefore, it's not critical. One pump fails, the other pump will kick in. It's not my concern. But you want to monitor contamination. You want to make sure that this lube skid is providing clean lubricant to the machine. Well, then you would sample from the filter outlet. Or some people decide to do both the filter inlet and the outlet. I'm not a big fan of that one myself, but at least the outlet. That would confirm you're providing clean lubricant to the machine. Now again, some people look at this picture and say, but we already decided the pumps are not critical because there's 2. They might decide that the filters don't need a sample to confirm they're working because they've got differential pressure indicators on them. And as long as the differential pressure is where it should be, we'll assume the filters are working. So that is not a good sample point anymore if we have that logic. So what would we like to do next? Maybe we'd like to change the oil based on condition. So we want to know if the oil is suffering, if it needs replenishing, replacement. So where we get that data would be by sampling out of the reservoir. Now at this point, it doesn't really matter if it's the top or the bottom. We can sample any point in the reservoir and we'll have enough information to know when to change the oil. But lastly, we go through this one more time and we say pumps are duplicated, they're not critical, filters have differential pressure indicators, they're not a problem, and we change the oil on schedule. So we don't need to know the oil's condition because we're going to change the oil once a year, whether it needs it or not. What we're really concerned with is how is that piece of equipment that it is lubricating. Well, to get that information, we want to sample on the return line before the oil goes into the reservoir. That would be our optimal sample point. So hopefully you can see that any one of those sample points was a decent sample point, but it depended on what you wanted to find out. And you're not going to find out all 4 answers from all 4 sample points. So you need to pick which particular criteria is the most important to you, and that will help guide you as to what is the most appropriate sample point. Now, some of the criteria that we need to consider as well is, are we even going to get the information? So generally speaking, if the test that you're looking to have the data from is related to wear or contamination, it will be affected by sample point location. So any of the particle counting, water content, things like this, definitely will be affected by where the sample is pulled. But if the data you're most interested in has to do with the physical or chemical properties of the fluid, like viscosities and acid number or base number, then it really doesn't matter where you take the sample, that data will be unaffected by its location. Now, what we're looking for when it comes to a sample point location is to make sure that we have live circulating hot oil. And generally where we can find that is within the normal flow of the oil. Generally, we prefer to get it on or after an elbow, upstream of a filter, downstream of a pump. And you can keep reading down the list on the left there and see other things that help give you good circulating live oil. What you really want to avoid, though, is the things that are on the right-hand side of the list here. You want to avoid the dead legs of piping or particularly long runs of piping. Anything that would cause the oil to allow particulate and water to settle out or allow it to just sit there and stagnate and not recirculate with the rest of the oil. Sometimes you don't have a whole lot of choices. Sometimes there's only 1 or 2 places you can even pull the oil from. But use your best judgment to say, is this giving me live circulating oil as best as the other choices I have in front of me? And above all, we tend to avoid drains. That's one of the few times that even though there's oil behind it and it may be close to the working area, we try and avoid it if we can, see if it can't come in from above. So with that, I need to show you some of the tools that help you pick and choose which location might work better for you. So with these tools that I'm about to go through, my goal is that the first thing we're always going to need is a sample bottle, and I'd like to show you what not to use. So here's examples of sample bottles that have actually hit our lab, and hopefully you can understand some of the downsides of using a bottle like these. So starting up at the 12 o'clock position, you can see the coffee cup, right? Somebody figured out how to package up a styrofoam coffee cup. That's probably not a very clean vessel. It's going to be open to contamination the entire time it's being shipped. It's a bit dangerous to send it this way. We'd really prefer that you didn't do this. Moving around counterclockwise off to the left, you can see beverage containers. We have received every kind of beverage container you can imagine: Coke products, Pepsi products, water bottles, iced tea bottles, Gatorade, sports drinks, whiskey bottles, you name it. Really raises some questions as to why that bottle is even on site. Down at the 6 o'clock position, you can see that we've got, kind of a Jelly of the Month Club selection there, as well as some makeup containers. Right? You just have to ask yourself, were these cleaned before they were put into a sampling location? I'm guessing the makeup one wasn't, because I can still see some of the makeup. But if you keep going around the clock there to the 3 o'clock position, you should see a Fuji water bottle. Now, if you look at the oil, can you tell what's wrong with the oil? It kind of looks like there's water in it. So now this begs the question, is there water in the oil, or was it just water in the bottle and it's not mixed in the oil? So it's misleading things like this. The contaminated or reused sample bottles are just going to constantly prompt questions but aren't really what you're trying to find out. So returning to the 12 o'clock position, we've got ourselves a bottle of Gatorade. Let's take a closer look at that Gatorade. If you go down the ingredient list of Gatorade, I've highlighted in red all the ingredients of Gatorade that actually could show up in oil analysis. Like, not all of them would, but some of them would. And the problem is that you see the ones that are listed there in red, the bottom two in particular are very concerning if we saw them in oil. Because the thing about most of these indicators is they would give us a false positive for a coolant leak. So if you sent us a sample out of your own personal vehicle, used a Gatorade bottle with residual Gatorade in it as your sampling container, we might actually send you back a report that says, to the best of our analysis, we're concluding you have a coolant leak. Right? That's how easily we can be misled, because it's got the same indicators in it. Those food additives have potassium and sodium in them, and those are some of the key things that we look for as a check for antifreeze contamination, because it has similar indicators in it. They're not the identical chemicals. I'm not telling you you're drinking antifreeze. I'm telling you that from an oil analysis perspective, it's indistinguishable. So we need to start our sampling program with the right tool, and the first tool we need is a good bottle. So here's ASTM's definition of what a good bottle would represent. Number one, it must be clean. It says if you suspect it's not clean, if for whatever reason from opening it, it may have become contaminated, simply rinse it with your sample. Right? So flush your sample point, but flush it through the bottle, you'll get yourself a good sample container. Next, it says appropriate for whatever handling is required. Well, it just means it has to survive shipping. So you want to make sure you package it in a way that is contained, the lid's on tight, things like this. Next, it says it has to be resistant to the materials. Well, that's pretty obvious that you don't want a bottle that's going to dissolve when it comes into contact with the oil. You also don't want it to melt if it comes into contact with the temperatures at which you're sampling it. But last but not least, it says appropriate for the analyses required. So a very fancy way of saying it's big enough to get all the tests you want. So we always ask people to use our sample bottles, which are 4-ounce sample bottles for the basic testing, and we have larger bottles if you need to do some more advanced testing. But sending us just a little scraping of oil in a tiny little bottle sometimes will not be enough sample to do the analysis, even if the sample integrity seems sound. So please always use a large enough container. 4 ounce is the minimum. Now, one question that seems to come up from time to time is how clean are the sample bottles that are supplied by oil analysis labs? Well, there is a criteria out there published by ISO that defines bottles as clean, super clean, and ultra clean. And these terms are used when you buy bottles from certain suppliers. And clean versus super clean is simply as a statement regarding how much of an influence will the bottle have on your particle count. And as you can read there, a clean bottle will have upwards of 100 particles greater than 10 microns influence on your particle count. It drops 90% to only 10% of that value, drops to 10 particles if it is a super clean bottle. However, an ultra clean bottle is a bottle that was assembled in a clean room. And a clean room is defined as a particulate-free environment. So arguably an ultra clean bottle has 0 particulate in it. So people like to know, well, what kind of bottles do we supply at Test Oil? We don't supply you with any of these. Reason being, and that's the bottom bullet there, as soon as you open up one of those bottles, that warranty, that guarantee is absolutely void. So there's no point really investing in a super clean bottle or an ultra clean bottle only to open it up in an outdoor environment with natural airborne contamination and maybe even process-related contamination just floating around in the air that's going to enter that bottle the moment you open it. So again, I always go back to the statement ASTM made. If you have any suspicion the bottle is not clean enough, simply rinse it. And the bottles we supply you from Test Oil are brand new, never used, and they are sealed. But we make no claims as to how clean they are. We just assure you they are brand new and reasonably clean from the point of manufacture. Really, the onus is on the person taking the samples. If a bottle is going to be too contaminated in a way that will affect your analysis, it's almost never the bottle's fault. It's going to be the person taking the sample has left the bottle open too long or placed the cap down on a dirty surface or some other procedure that lends itself to adding contamination. So with that, we know that we can deal with a general bottle from a lab. It's going to be clean enough. We'll make sure we rinse it. But we'll get to that when we talk about procedures. Other tools we may need to get oil into the bottle, though, may rely on adding some sort of port or valve. So I'd like to show you some examples of these just so you know they exist. If you're curious where to purchase them, the website where I've obtained all these is always going to be in the bottom left of every slide. So it'll tell you where you can look these up if one of them happens to catch your fancy. Now, as I show you these, my goal is to show you a tool that's going to make sample taking go quicker, easier, and with greater consistency, because that, of course, is one of the consistencies we're going for, but also to reduce the contamination that may enter the sample while the oil is in circulation or while the bottle is being filled. Now with these, most of these valves I'm about to show you have choices behind them. You can choose which metals they're made out of, so you usually have a stainless steel option if you're worried about a corrosive environment. They all have pressure ratings, some of them as high as 9,000 psi, so there's generally no situation you can't find a valve that will work regardless of system pressure. And they have different thread choices as well. So if you're dealing with MPT versus metric versus left hand, there's almost always a variation that you can either purchase it with the correct threading or push it down to the correct threading. So without further ado, let me quickly run through these and I'll show you the top 3 that I like to recommend when I'm visiting customer sites. So first and foremost, this is my most popular recommendation, is a variation on the mini mess valve. It threads in, it has a thread on dust cap, it has a female valve as part of the sample valve. You use a male adapter to open it. So the adapter tends to be thread on and it's able to control the flow, so it's easy if you're dealing with higher pressures or higher flow rates. Now some people may look at this picture and realize the orifice in the center of that female valve is only a 1/8 inch opening, and they may think that's pretty slow for flow rate. There is a high flow version that's got a 1/4 inch opening. Now, for those that don't like the idea of a thread-on adapter, needing to take the time to screw an adapter on and off between every sample, there is a version called KST, or Provolizer, which does not use a thread-on, it's a push-on. So it still needs an adapter, but it's very quick to insert it into the orifice and push it in until you open the spring that opens the valve. Now, what I like about these styles of mini mess, and this is probably the variation that I most frequently recommend, is that they can all be mounted to a pitot tube. A pitot tube allows me to thread this in through the casing of a piece of machinery, but reach in to the live circulating area and know that I'm not getting simply the stagnant oil against the outer casing. So that is probably the one that I recommend most frequently. If you're not interested in carrying around adapters or needing an adapter to pull a sample, they make a push button version. The push button version just uses your thumb. Push it in and it opens the valve. Obviously, these aren't as rated for as high a pressure, but for many systems, it works. Now, the nice thing about anything I've shown you so far is it's pretty easy to find a way to change the piping and add it in. You can change an elbow to a T, you can break a union and add in an extension. You can do all kinds of things to add them in fairly simply, fairly easily. So generally speaking, as long as there is an existing piece of hardware like a filter or any piping, there's probably a way to add this in with minimal disruption during a scheduled oil change. Some people do complain that they stick out a little bit, and if you're dealing with the mobile industry in particular, that may be a problem because you may be worried about the valve shearing off. Well, for those people, I would say look at these. They're flush mount versions that are recessed into generally a drain location. They do have pitot tubes on the backside, so you can reach in and they'll be away from the very bottom. This is probably the second most common one that I recommend. It allows people who deal with sight glasses to upgrade their sight glass to a better sight glass, a 3D sight glass, but also insert a basically mini mess with a pitot tube as well. You know that the oil should be approximately at the level of the sight glass, so the pitot tube is bent downwards to ensure that you're not going to suck the air out if you're using a vacuum pump. These are very nice additions to almost any type of bearing housing, pump housing, and in some cases, even the odd gearbox or other pieces of machinery. If you're dealing with a drain, like you would be commonly dealing with on a gearbox, they make these versions here that thread into your pre-existing drain and just move it off to the side. In this case, in the picture, the right-hand side becomes your drain now. Straight through the middle is a pitot tube, which you would bend upwards to get off the bottom. And to the left option, you can add a level gauge in case you had no previous way of confirming the level outside of, say, using a dipstick. If you already have an external level gauge, there's a way to swap it out with one that includes a pitot tube. So this is just an easy way to take the pre-existing tank or reservoir level gauge and add in a sample point. If you have thin-walled tubing, this version allows you to clamp it on and install it while the machinery is running. You don't have to shut down to install this one. It is able to be installed under pressure, under flow. As you clamp it down and it tightens on the thin-walled tubing, it will puncture a hole in the tubing, allowing flow through the tubing, but still be sealed and directed towards whatever you want to thread into the plug on the outside. So in this case, on the picture on the right, you can see it has a mini net style. But this one here, this is the third most common one that I recommend. I like to recommend the pitot tubes. I like to recommend the bullseye sight glass ones. And I also, for some of the reservoirs, particularly on hydraulic systems, like to recommend this one. If you're familiar with the quarter-turn breathers, the little gaskets they have underneath them, this basically, you remove the collar that holds that basket, and this manifold threads into the same 3 or 6 hole bolt pattern. The manifold that you see there, kind of a hockey puck looking thing towards the bottom, it has a sampling port on the side facing us, and it's got the pitot tube going down into the reservoir. On the back side, it's got a quick connect to allow you to fill without needing to open up the system, and it's got a proper desiccant breather on top of it. The desiccant changes color, so you would know if the desiccant needs to be changed, and the little filter performance indicator off to the right will tell you if the air filter needs to be changed. So this basically upgrades your fill point to a sealed, closed, if you want to refer to it that way of filling your reservoir. It allows you to pull samples from the live zone, and it has a much, much better protection on the breather side. Now, getting towards the end of things I need to show you, if you're dealing with hydraulic hoses, there is a way to add an extension. Basically, it's just a spacer, and it has a hole threaded on the side. You can add whatever sort of mini mesh or valve you'd like to one of these. If you have a return line and you want to sample from there, return lines are notoriously vertical and not flooded. This is just a pipe piece that you can either thread in or weld into your pre-existing return line, and has a little deflector plate on the inside to splash some oil over towards a mini mesh style valve. I will warn you, this is a very slow way of taking a sample, but at least it allows you to get the sample from the return line before the oil has been diluted by the reservoir. Now, just for fun, if there's anybody out there planning on taking a certification exam, and this is one of the questions they like to ask about sampling tools, and the question is, what is a bacon bomb? Bacon bomb is what most of us would call a thief sampler or a sample thief. It's one of these devices that you lower through the thief hole of a large reservoir, so a bulk oil or bulk fuel tank. And when these things are lowered into the tank, when they hit the bottom of the tank, the little nubby on the bottom pops the device open, it floods. When you lift it up, it closes, and that's how you grab samples from the very bottom of large tanks. This is usually used to determine if there's any sort of stratification of materials, maybe different products, or of course, particulate in the water. So it's not a common device, but like I said, for anyone writing an exam, you might want to know that one. Take note. But the one thing I'd tell you about all of these sample tools is they're all designed to do a particular task either simpler or more conveniently than trying to do it through openings, hatches, dipsticks, whatnot. But the one thing I would never take away from you is to say that a quarter-turn ball valve is not a proper sample valve. It is. It works just fine. It's quick to open, quick to close. It's easy to adjust the flow. It's very easy to flush it. It works very, very well. The only thing I'd recommend is if you're going to use simple valves like this as your sampling valves, make sure on the output of the valve you have a 90. And make sure it points downwards. So it'll help minimize the contamination that builds up on the outside of the valve and reduce the amount of time that you're going to spend flushing it before you take your samples. So with that, it gives you an idea of all the tools that exist out there at the sample point. But one of the things you might need to supplement this is a vacuum pump, or sampling pump as some people call it, or even a vampire pump. These pumps are used for pulling samples from systems that don't have enough pressure that the oil will flow out freely on its own. So it could be low pressure, it could just be no pressure. But when you use a sampling pump, you need to make sure that you use it properly. Now, it's a fairly simple device. It's got some fairly simple steps to make sure you're going to minimize the effort it takes to do your sampling. So number one, when you insert the tubing into your sample pump, don't stop the tubing inside that pump body, that clear acrylic that you can see in the picture. Often it's yellow or red, depending on which vendor you get them from. Make sure the tubing goes all the way through the head of that pump. You want to make sure the tubing sticks out into the bottle. Now, this doesn't affect your sample. What it does is it maintains that your pump will stay clean. That's all it's doing. Now, the tubing that you have that goes through the pump body, I would encourage you to angle cut it at a 45-degree angle, not 90-degree cut. And again, this doesn't affect the sample. It just makes sure that the oil doesn't spatter as it comes up the tubing. And again, make sure that the pump stays clean. The last thing to note is that when you're taking a sample and you've got the bottle screwed on tight, you've got the sampling done up tight, the sample tubing, done up tight, and you've produced the vacuum, oil's flowing into the bottle, what happens if the flow is a little too quick for you? What happens if you think you're going to overfill the bottle? Well, a lot of people react very quickly and they pull the tubing out of the sample point. Well, that doesn't really stop the flow because the flow exists because there's a vacuum on the bottle. So the vacuum will still empty the tube into the bottle, which still may overfill even though you've pulled it out of the sample point location. So that's not really the good solution. Neither is trying to crimp the tubing like a garden hose. The tubing is simply not that flexible. It doesn't really crimp and seal well. Really, the easiest solution is simply unscrew the bottle. Grab the bottle, give it about a quarter turn. You will break the vacuum. You will stop the flow instantaneously. It's the easiest way to prevent overfilling the bottle. Now, if you're using a vacuum pump, you're more than likely going to need tubing. And definitely if you're following our procedure, because we recommend a new piece of tubing with each and every sample. We want to make sure that you're not reusing sampling tubing in any way. And to help you understand why, I could explain that there's the issue of cross-contamination and other things like this, but let me try and put it into an economic explanation. This tubing, if you were to go out to a store and buy it, is about 10 cents a foot. So as soon as you put any effort into flushing it, rinsing it, or trying to do anything to it, you probably spent more on labor and other parts trying to clean it than you are for its value. So don't reuse tubing. It's not worth your time and effort, and certainly, yes, it may affect your sample integrity. So a new piece of tubing with every sample, and bear in mind that even though it's new, it still requires some flushing. We generally recommend about 1 or 2 ounces for every foot of tubing. So most people typically use about 3 feet of it at a time. It means you're probably going to need to fill that 4-ounce sample bottle completely and then dump it out just to have considered flushing the tubing. So here's the upside. You'll have also flushed the sample point. You'll have also flushed your bottle. So it's not a bad practice to get into, and you'll see that when we get to the procedures. One quick little thing I'll note before we get that far, though, is that if you're sampling in a particularly dirty environment, this is a nice little tip that I saw in a magazine. Take your bottle with the lid off, leave it in a Ziploc bag, little sandwich baggie. Seal the baggie, and you've got yourself a bottle in a clean bag. When you go out into the dirty environment, you can take that bottle in the bag and you can still thread it onto your sample pump. Because as you can see in the picture, the tubing sticks out below the sample pump. It will poke into that bag and puncture the bag as you screw the bottle to the pump. When you go to unscrew the bottle from the pump, there's only a tiny hole in the bag. So the bottle will stay relatively clean in the environment and not pick up any additional contamination in the time that it takes you to push the lid up to the top of the bottle and thread it on. I know it might sound complicated at first, but I assure you, if you give it a few tries, you'll realize that this is in fact very easy to do. And you'll start to think that maybe you should just put every bottle in the baggie, and that way you just simply don't lose the lids anymore. So it's a nice little tip, little trick to sample when you're dealing with particularly windy, dirty environments, or even if you're in an area where maybe there's a steam leak and you're just worried about the humidity skewing your results. So nice little tip regarding taking oil samples. One final note before we move on is if you have grease. A lot of people ask us about grease testing. And certainly, yes, greases can be tested very similarly to how oils are tested. But of course, the follow-up question is how do you get the sample? Well, we don't want you just scraping it off the outside of a piece of machinery and putting it in a sample bottle. That's going to be full of contaminants. So there are various tools that exist out there, and some of the best ones are made by a company called MRG. They're called Grease Thieves, and I'm showing you 2 of their variations right here. One's an active sampler that you install by threading it into a purge. The other one's a passive sampler that you can, or sorry, the passive one you thread into the birds. The active one is like a core sampler. It's basically got a little stinger on it, and you just insert it, grab the sample. In both of these cases, once the sample has been obtained, you just simply put the cap back on them. You can mail them straight to the lab. You send the whole device in. So with that, we know that there's lots of tools that exist out there to hopefully shortcut how much effort it's taking us to take a sample, encourage more consistency for where we take the samples, and above all, reduce the contamination that may be present while we sample. So one of the last things we need to discuss is the procedure, and then we'll finish off with frequency. So the procedure is our second consistency. We need a consistent procedure. And what we want to make sure is that we keep it safe. We don't put anybody in harm's way taking samples. We want to keep it simple, as few steps as possible, maintains consistency, and reduces the amount of error. And we want to make sure that we, of course, avoid contamination while we're doing any of this. But above all, I try and keep it convenient. If it's convenient, people will do it. If it's inconvenient, if it's complicated, or if it's unsafe, guaranteed people won't want to do this task, and you're probably going to get some questionable samples coming in. So what we need to consider is that when we're doing this procedure, and we're going to try and keep it very, very simple, we need to get active oil. We need to sample live circulating oil. We need to make sure that we're not getting the dead zones. We need to make sure that everything that ends up in the bottle is what we want and no extras. Right? We don't hold the sample bottle underneath a valve that's so caked with dirt that as we open the valve, chunks fall off and end up in the bottle. If they end up in the bottle, it ends up on the report. It's going to look bad. And we also don't want to sample from an area that has a tendency for sediment and or water to collect. If it does, and that's our only choice, we must make sure we flush it so that we don't get that kind of data. So the way I look at it is there's really only 5 steps. You can say them in 5 words. In fact, they're only 5 syllables. So step number 1, when you walk up to a sample point you're about to sample from, wipe it. When I say wipe, I don't mean make it meticulously clean. I don't mean wipe a huge area. I mean wipe enough of it that there will be nothing extra getting into the sample bottle. So wipe the valve, wipe the dust cap, whatever it is, clean enough that you can manipulate the valve, manipulate the dust cap, and not get anything extra going into the bottle. Next, flush it. Now, some people out there have been promoting that you flush 6 times the volume of the pipe. That seems like a pretty good tip, except I don't know about you, but I can't do that kind of math in my head. I can look at a 1/2 inch pipe and a 3/4 inch pipe and tell you which one's which. What I can't do is tell you off the top of my head what the inside diameter is, multiply that by pi, multiply that by the length, and multiply that by 6 to tell you how much volume that is in terms of flushing it out of the sample pipe. So my logic is simply this: flush it till it's hot. If that oil is coming out hot, that oil is live oil. If it's still coming out cold, that is stagnant oil. You don't want that. So flush it until it's hot. So wipe it, flush it. Here's an easy step now. Fill it. Fill the sample bottle not quite full. We recommend about 75 to 80% full. We're asking that you leave a little bit of empty space. Now, this has nothing to do with shipping, expansion, contraction, anything like that. The biggest reason we ask you to send us a bottle with a little bit of headspace is because the first step we do to any sample reaching lab, we throw it on a mechanical shaker. And if there's no headspace in the bottle, it can't mix. We want to remix your sample so that it's as representative as the moment you took the sample, even if it's taken a couple of days in shipping to get to us. So wipe it, flush it, fill it, but not quite all the way. Once you've got it full, cap it. Close the bottle before any external contamination can get in. And if you have not already, this is the best time to label the sample. You can write on the lid. You can affix the sample labels that we provide to you. If you get your labels in advance, they can even be pre-printed for you. So you can have almost all the sample information already written on them. So really, you're just filling in perhaps the date and whether or not the oil was changed. But above all, once you've got all these steps done, the next and final step is send it. Right? Too many times people call and wonder where their sample is, what's taking so long. And at Test Oil, our turnaround time for all samples under routine testing is same day. Everything that comes in today is out today. So our turnaround time is the same day it was received. So if you've been waiting more than a day or two for your results, well, then it's lost in shipping somewhere. So talk to your shippers, Talk to your people taking samples and see how they're handling this side of it. It's one of the greatest causes for delays in getting results. So make sure the person who's taking samples knows to drop them off at shipping right away. Make sure the person who's responsible for shipping knows to send them out right away. Right? Don't wait to accumulate full boxes or bags of samples. Don't wait for other reasons to say, well, I don't like to send in them one or two at a time. Shipping costs are very, very affordable, and the average shipping time for most places within the country is generally overnight, if not 2 days. So there's not much reason to expect that any of this should take that long. And like I said, above all, our end of it is among the quickest. But anyway, there's your 5 steps. 5 syllables, 5 words. Wipe it, flush it, fill it, cap it, and then send it. Pretty simple if you think about it, but that's the point. It is supposed to be simple. There's no magic behind how you take samples. There's no mystery as to how it should be done. But find a way to do these 5 steps in a way that is as simple and as convenient and, of course, as consistent as possible. Now, our last consistency that we need to talk about before we finish up is frequency. So I'll try and get through this a little bit quickly, just so we're not holding you here too long. But this is the third consistency, and it's one of the most overlooked consistencies. A lot of people don't realize the importance of this. Right? If you plan to take samples quarterly, you're going to take samples every 90 days. If you take samples every 90 days, every 90 days, every 90 days, and then one day you miss it. One day it doesn't work out. You can't do it. So you reschedule it for the next month. So you've got this history of sample results every 90 days, every 90 days, every 90 days. Well, now suddenly we get one that's at 120 days. That's not too big of a deal, really. But here's the issue. What do most people do for the next sample? Well, a lot of people try and get back on schedule. So they take the next sample when it was originally scheduled to be taken, not 90 days from the last sample. So when they take the next sample, it's taken at 60 days from the last sample to be back on the original schedule of every 90 days. So what we're comparing is 90, 90, 90, 120, and then down to 60. That really throws off the trending. It makes it difficult to see if the trend is smooth when you have inconsistent intervals like that. So I'm not saying you have to be down to the exact day or the exact hour of testing. You have to just be consistent enough that you know it's not going to add too much noise to the sample data. So when we're trying to pick that interval, one way you could determine this would be to use your PF intervals. And that logic works really, really well for ultrasonic sonography and vibration. It does not work for oil analysis. Some people decide to do 1/2 PF interval for their sampling intervals. If you were to do oil analysis that way, you would miss the trend. You wouldn't see it. It's not often enough to catch a drop that would occur. Some people then say, well, why don't we increase the interval? Why don't we take samples more and more frequently as we approach F, once we've determined P? Well, again, that's actually misleading. That's going to cause you more harm than good. And just to give you a quick explanation on that, let me show you some data. Imagine our data from sample 1 to sample 2 to sample 3 goes from 5 ppm to 9 ppm to 15 ppm. Let's predict what the results would look like at sample number 4, assuming that data is normal, and then assuming that data is abnormal. Then let's also imagine what would happen if we reduced the interval by half, if we decided to take a sample a bit sooner because we were a bit concerned about this data. So assuming it's a normal trend, if it goes from 5 to 9, it's an increase of 4. If it goes from 9 to 15, that's an increase of 6. On average, that's an increase of 5. So what should the data look like if it's following a normal trend? At sample number 4, probably 20. Right? That would follow the normal trend. Okay? What would it be if we sampled at a half interval, though? Halfway between sample 3 and 4. Well, it would be halfway between 15 and 20. It would be 17.5. Okay, but now, just to hold on for a second, and let's look at it from an abnormal perspective. If it increases from 5 to 9, and then from 9 to 15, that's an increase of 4 followed by an increase of 6. What might the next increase look like? It could be an increase of 8. So what would the sample result at sample number 4 look like? It could be as high as 23. Now, what would it look like if we took a sample at a half interval? Well, it's not going to be exactly halfway between 15 and 23, so it's not going to be 19. It'd actually be slightly less because it's kind of on a curve now. So it would be 18.5. That would be the expected value. Here's my point. If after sample 1, 2, 3, we think something doesn't look right, If we wait till sample number 4 and just take it at a normally scheduled time, if it was normal, it would look like 20. If it was abnormal, it would look like 23. I think that's an easy difference to spot. But if we decided that we were going to take it early, take it at interval 3.5 as an example, we're now trying to compare the difference between 17.5 and 18.5. And to be honest, we don't report decimals on this data. It'd be rounded to the nearest whole number. So both of those results could come back as 18, depending on the exact value behind it. And what did you just learn? Nothing. You don't know if the trend is normal or abnormal. So wait a normal interval and don't get your data too soon. So I'm showing it to you graphically here, just showing you the trend of the orange line being the abnormal trend, the blue line hidden behind the orange line being the normal trend. And at sample number 3, you don't know where it's going. You don't know which line is going to follow. The sooner you resample, the less obvious that difference is. So don't sample too frequently. So that begs the question, well, what is frequent enough? So this is a study done by Chevron. It's on vibration analysis. This is not oil analysis, but it shows us the Goldilocks principle. If you look on the left-hand side, they used to take vibration readings every 60 days, every other month. And they caught about 2/3 of the problems they felt vibration should have caught. They weren't happy with this. So they increased the frequency, doubled the readings, the sampling every 30 days they took a vibration reading, and they saw a 30% increase in the number of faults they were able to detect. So they were very pleased with this, and they said, well, let's just keep going. Let's increase the frequency again. Let's double the sampling. So they started taking 2 readings every month. Every 14 days, they got a new vibration analysis reading, and they increased the number of faults by 2%. So there's such a thing as not often enough. There's such a thing as too often. And there's such a thing as just right. So how do we find out what just right is? Well, one of the tables that you could refer to is from the Basic Handbook of Lubrication. It recommends that most engines are sampled at drain, and most industrial equipment is sampled about quarterly. Generally speaking, quarterly is kind of a good answer. And that's just one source of information. Another one is ASTM. If you look at the very top row of this table, ASTM standard for in-service monitoring of auxiliary power plant equipment, ASTM D6224, recommends quarterly. Again, quarterly, quarterly, quarterly. If you look across that whole list, it's pretty much without exception, everything's listed as quarterly. There's one exception that's on the list there, and it seems like there's one blank. Diesel engine oils are not blank. It's the footnote at the bottom of this slide here. It says every 250 to 500 hours if it's continuously operated, every 6 months if it happens to be standby. So those are really the only exceptions. By and large, you assume quarterly. And that's kind of the last thing I'd like to cover here is that when you're trying to decide on a sampling frequency, there is no easy set answer that says, here it is. Here's how often you should always sample it. There's guidelines, and these guidelines should be considered as starting points. You have to take into account other factors like the environment in particular. Maybe load, maybe temperature, maybe speed, right? Those are the 4 most common things that could drive us to being able to sample less frequently or require us to sample more frequently. But I've given you a list of a few other things here that help guide you as to what else might be taken into consideration to affect your frequency. So generally what I do when I do an audit is I walk myself through essentially that. I assume quarterly. Blind faith quarterly is where I'm starting from. Now, what I ask of the end user is this a critical piece of equipment? Because if they say, yes, it's critical, I may consider sampling more frequently. But if they say, no, it's not a critical piece of equipment, I may decide to sample less frequently. Then I'll ask again that question, is it expensive, right? If this thing goes down, does it cost your company a lot of money in parts, labor, downtime, regulatory fines, whatever it might be? If you say yes, I may decide to go more frequently. If you say no, I may go less frequently. Then I'll ask you, are you using this analysis to determine when to change the oil? If you say yes to that question, I'll temper my answer so that we get about, maybe 3 to 6 data points per expected drain interval. What I mean by this is if you told me it was critical and you told me it was expensive and we're leaning towards monthly, but you tell me you're using this oil to determine an oil change and the oil's life expectancy is 5 years, I don't think we need to take monthly samples to schedule a 5-year, interval on an oil drain. Right? That's 60 data points. We don't need that much data. So I'd probably back it off to something like semi-annual at the most, and that would give us enough data to be able to schedule the oil change. But if you say no, I change oil once a year whether it needs it or not. Again, I might temper my answer because why would we analyze something monthly if you're going to change oil after 1 year regardless of what happens? So that one's a bit more up in the air. The last question I'll ask is it a large volume? If it's a large volume, I know this makes the indicators in oil analysis react more slowly, right? It causes them to lag a little bit because you're diluting everything with a large volume. So we need to decrease our frequency if we're sampling large volumes. If it's under 200 gallons, though, we probably leave the frequency right where it is. So just to finish off and give you a couple quick examples, if you told me it was critical, it was expensive, and you're doing this oil change, based on the data, we might actually lean towards monthly. But if you say no, change it once a year, whether it needs it or not, then of course that would give us a different answer. But the biggest driver is the volume. Right? A small volume, you might stick to monthly, but a large volume, I'm going to back you right off to quarterly again. So like I said, quarterly, quarterly, quarterly. That's a pretty decent sampling interval for most systems. The exact opposite though, what if you told me it was not critical, it was not expensive, and you change the oil once a year whether it needs it or not? When I go to power plants, this is like cooling tower gearbox. That's a great example of this. I might look at you and say, why are we sampling this? Right? What possible value do you have in oil analysis if you're going to change oil once a year and it's not really a critical or expensive piece of equipment? Right? Maybe we focus that budget somewhere else. So you can see with these two examples here, it varies, but without question, you can always start with quarterly and see your way from there. So with that, just to quickly summarize here, understand that yes, proper sampling is the foundation to success of your oil analysis program. Without a good sample, you don't get good data. Without good data, you don't get a good interpretation. The whole program falls apart. The location is far more important than the procedure because you can always modify the procedure later. Make sure that you've got the hardware that makes the sample taking as quick and painless as possible for the person sent out there to sample, because it will help ensure that it's as consistent and contamination-free as possible. The procedure should be as simple as it can. Understand that just because it's simple doesn't mean it's easy. A simple procedure is also simple to make mistakes. But the simpler, generally, the better. And above all, take samples often enough. Right? And if you want to know what's often enough, and my previous guidance there wasn't helpful enough, start with quarterly, and if you ever have a problem, sample that particular machine a bit more frequently. You don't need to modify the whole program for every machine, but just the ones you've had issues on in the past. So with that, I've gotten us through the whole presentation. I will turn it back over to Heather now in case there's been any questions along the way, but I do thank you for taking the time to listen to us today and hope you got something out of it.
Yes, thank you, Evan. That was really great. It looks like we have one question currently, and they were asking if it takes a week to get all of the samples and they have everything sent off together the next time that they pull into port, does the difference in age between the samples or the delay before sending them in make a difference in the results?
That's a great question, and the easy answer is no. We've dealt with, in particular, like navies and whatnot, and sometimes they're out to sea for 3 to 6 months, and they collect samples at their normal intervals. And because of the procedures that we use when we receive your sample to shake it and mix it all back up, no, there's no issue with the sample sitting for a week, or I don't really like to tell people this, but it's the truth, even for months. No, the sample integrity is still pretty solid. Samples do continue to degrade even after they've been sampled, but the rate of degradation is so slight that it's not going to skew your data analysis in any meaningful kind of way. We of course just encourage you to send them in as quickly as is practical. So if you're speaking from a marine perspective where, yeah, you only import every now and then obviously you do have to wait. You're not going to airlift them out of there. That's not cost effective. But no, a week or two, don't worry about that at all. Even if it happened to be upwards of 1 to 3 months, we don't really concern ourselves. We understand the logistics. And like I said, we take the steps to make sure that we minimize any effect that sitting for a long time in the bottle will have.
Mm-hmm. And I think if you are worried about that too, you can also keep in mind, try to keep it in a dark, cool place while it's being stored until you can have it sent to your laboratory. And it looks like we definitely have one more question. So they're asking about sampling guidance for bituminous-based lubricants. I'm not sure if you'll know that offhand or not, Evan, but we can always take a look.
Sorry, for what kind of lubricants?
Bituminous-based lubricants. That one we might have to look into a little bit and see if we can find some more direction.
Yeah, I think we'll have to answer that one via email.
Mm-hmm. So, and then our next question was, sometimes samples are taken a month beforehand, so are they still good for analysis? It sounds like you kind of answered that with the maritime question, that they will still be good for analysis. You can just take precautions by keeping it in a dark, cool space. And then the laboratory also takes precautions and agitates samples as they come in.
Yeah, I mean, we don't encourage this behavior of letting samples sit for a month, but if logistics dictates that they have or will, yeah, it's not the end of the world. Yeah, I think the was answered by the previous question.
And then we also have, someone is asking if you can give some advice when they want to sample from a refrigerant compressor.
Probably that question, if I was to guess, is coming from somebody who's wondering about the gas entrainment that occurs. So yeah, when you're sampling that, it's quite likely you get a lot of excessive foam happening. So two things. One is you might want to use a larger sample container so that you're not worried about having too little sample once the foam all settles. But the other part of it, usually people wonder about the gas. So there's two schools of thought on what to do about the gas, and one school is nothing, and the other school is something. And with the something, there's two versions of that as well. And I guess the answers would be do nothing, degas it on site, or degas it at the lab. And let me just walk you through those last two real quick. So to degas a sample on site, meaning the person who takes the sample degasses the sample, really the only easy way for somebody to do this is to leave the cap off. And when I say off, I don't mean like completely removed sitting on the table. I just mean loose so that it's not sealed. Mm-hmm. If you let it sit for a couple of days, eventually most of the gas will evacuate and you'll have less of an issue. You can ask labs to degas it, whereby we use sonication and vacuum to help remove those gases. Now, the reason I said there's two schools of thought, and the first school was the do nothing, is because that's my school of thought. I'm not saying I'm right. It's just what I prefer. The reason I say do nothing is that to degas a sample, to remove the refrigerant, and to see the oil without the refrigerant may provide you with some data you think is better, but my logic is it's circulating as a lubricant with the refrigerant. So I kind of like to see it unadulterated with the refrigerants in it. Mm-hmm. And the only issue that you're going to have is that the viscosity will read low. And that's just expected. And as long as you consistently take the samples and we consistently test them with the refrigerant, we can still trend that viscosity. And we can still tell you if there's an issue. Now, if we were to consistently degas it, whether the customer did it or the lab did it, again, we can still trend that. But I'm just not of the favor, I guess, of doing it that way. I don't see much logic in needing to necessarily remove the gas just to see the viscosity in a perfect state, which it is not when it's lubricating equipment anyways. But getting back to my first point, I understand that one of the other aspects is volume. That as you're filling the bottle, because there's so much gas getting in there, you may find that it's filled with foam, and that by the time it does settle, you've got a half full bottle and you're like, ooh, I don't know if that's enough. So yeah, take two bottles or take a larger bottle with you, and that'll help make sure that we at the lab get enough sample. And when we get the sample, we will shake it up, which doesn't really degas it or anything like that, but just mixes up everything else, and we'll test it as it was received. And so hopefully that answers your question. If there's anything more detailed than that, like where on a compressor you might want to sample it, we could always answer that question via email. But generally speaking, most people take it from where the oil separator is located or just upstream of the filters are two easy to access points. So you can either add a valve, or sometimes on some brands, there is already a sample valve located there.
Mm-hmm. Thanks, Evan. And We are 5 after the hour, so we'll take a couple more questions, but otherwise we will ensure that Evan gets back to everyone over email. And let's see, our next question here. In the test oil analysis report, does it recommend saying you should replace the oil?
Well, we may from time to time, within a comment, that may be one of two suggestions, but we are not the final deciders of that particular action. The reason that you have to appreciate why a lab will never ever say to you, absolutely without fail, you must change your oil, is we don't understand what it takes to do that. Right? When you send us in a sample, we don't know necessarily that's a 5,000 gallon system. You're going to need 2 rail cars worth of oil. You're going to have to shut down, go offline, suffer regulatory fines. We don't know this.
Mm-hmm.
So a report's not going to come with a pat statement that says, thou must change your oil today. We may put it as part of a recommendation saying, yes, maybe the acid number is so significantly high, maybe other degradation characteristics would suggest that replacing oil may be one of the only options. But if you truly want an answer to that question, then it's best to phone us and talk to us directly and help us walk you through interpretation of the results where we can share information back and forth to help decide if that really is the only course of action. Because generally speaking, there's usually more than one choice. Mm-hmm. Sometimes you can filter, sometimes you can bleed and feed, and in certain cases you can actually re-additize the oils. There's lots of options that exist. But no, a report's never going to come back to you with a definitive, big green check mark beside change your oil, is the only option.
Right. Very true. And then we will take this one as our last question. So we have a multi-stage equipment, it's a compressor to gearbox or motor, driven by the same lubrication reservoir. Do you recommend that we take samples from all 3 pieces of equipment?
That would be considered secondary sample locations. Most people have a primary one that is just one bulk location for all 3. And until they see a variation in that particular sample point, they wouldn't go back and sample all 3. So generally the answer is yes. With a shared lubrication system, if you can get it off the return line before the reservoir, on the header where all of them are dumping it back in, that's one of the best locations possible. If each machine feeds directly back into the reservoir independently, then you're probably best to sample directly out of the reservoir. Otherwise, it could be skewed by just one machine. So if you're going to do that, try and do it at the return side, not the suction side of the reservoir, if it exists, depending on the configuration. But no, you don't need to sample all 3. They're all sharing the lubricant. The analysis is not that detailed to be able to tell you, bearing wear from the electric motor compared to the gearbox compared to the pump kind of thing when you have shared lubrication systems. So we just monitor it as the whole through that one primary location. And you can consider, like I said, if you wanted a backup sample point at the return lines of each individual machine so that you could try and isolate which one in particular is causing the problems if the primary ever showed you a problem.
Perfect. Well, Evan, thank you very much for presenting on our webinar today. If anyone has questions, please feel free to contact Evan directly at ezabowski@testoil.com. It's at the bottom of the screen there. And otherwise, you can find more information on the testoil.com website. We have a blog where you can search for specific information. And if there's anything else we can do to help, always feel free to reach out. Thank you very much, Evan. Have a nice day.
All right. Thanks.
Okay. Take care, everyone.